Okay, welcome back. This is Mr. Hassan's Maths channel, and I'm now answering question number 10 from the February-March 2022 IGCSE Cambridge 0580 paper. This is from February-March 2022. Here we have a question about sequences. So part A says the nth term of a sequence is n squared plus 7. Find the first three terms of the sequence. So this is the general term of the sequence. So any term we want to find, you can find it very easily. They want the first three terms. So the first term is when n equals 1. So you just replace the n with 1. So you have 1 squared plus 7. That's going to give you 1 plus 7, which is 8. So that's the first term. And the second term is simply when n equals 2. So you're going to have 2 squared plus 7. Well, that's going to give you 4 plus 7. Okay, 4 plus 7 is 11. So that's going to be 11 here. And then the third term is going to be when you put n equals 3. So here you're going to have 3 squared plus 7, which is going to be 9 plus 7, which is 16. Okay, is that right? Yeah, 16. So there we have the sequence. The first three terms generated, pretty simple. Just replace the n with the numbers 1, 2, and 3 to find the first three terms. Then part B says these are the first four terms of a different sequence. So here we have a different sequence, and we want to find the nth term of this sequence. So when you want to find the nth term of a sequence, here we're doing the reverse. Here we have the terms and we want to find what the formula is for it. Now the first thing we need to do is to look at the differences between the terms. Okay, we see how does the term change, from one term to the next. And here we can see that from 15 to 7, you have to subtract 8. And then if I want to go from 7 to negative 1, I have to also subtract 8, because I've got to go to 0 first, at 7, and then another one, subtract 8. And again, from going from negative 1 to negative 9, again I have to subtract 8 again. If you're not sure how to deal with this, you can just take your calculator. If you're not very good with especially negative numbers, you take the second term and subtract from it the first term, and you see that means you have to go down by 8. And then you take the next term, negative 1, and you subtract the term before it. Whoops. You take the term before it, negative 1, and you subtract 7, and you see you get negative 8. And the same thing, negative 9, you take negative 9, and you subtract from it negative 1, it's going to give you again the same number. So you see that every time you go down, every time you go from one term to the other, you're going down 8 terms. That means this sequence has got something to do with the negative 8 times table, because it's going down in 8s. Alright, so the big mistake people make here, they'll say n minus 8. No, it's not n minus 8. It's got something to do with negative 8 times n. That will make something go down in 8s. In n equals 1, it will be negative 8. N equals 2 will be negative 16. 3 negative 24. 4 negative, it's going down in 8s that way. But we don't only want it to go down by 8, we also want it to start from 15. We want the first term to be 15. If I leave it like this, it's going to start at negative 8. The first term will be negative 8. And then it will go down by 8 each time. But I want it to start from positive 15 first and then go down by 8. So I think to myself, how do I go from negative 8 up to 15? I have to add something to negative 8 to make it become 15. Well, from negative 8 to 0, I have to add 8. And from 0 to 15, I have to add 15. So in total, I have to add 23. So it's going to be 23 minus 8. In fact, let's write it like this first. It's like minus 8n plus 23. Minus 8n plus 23. That's going to make my term start from 15 and then go down by 8 each time. And we can test it out. When n equals 1, we'll have minus 8 plus 23, which is 23 minus 8, which is 15. When n equals 2, you're going to have negative 16 plus 23, which is 23 minus 16, which is 7. When n equals 4, you have negative 34. You have negative, so when n equals 3, you have negative 24 plus 1. Negative 24 plus 23, which is negative 1. Right? So when n equals 4, you'll have negative 32 plus 23, which is negative 9. So the values that we have here come up when I put n equals 1, 2, 3, and 4 into it. So we know we're correct. And you can leave your answer written in this format, or you can write it as 23 minus 8n looks a bit neater. Both of them are perfectly fine. So that's the answer to 10a and 10b. This is called a linear sequence, where you have to add something each time to get to the next term. You'll find that that's different from this type of sequence. This is called a quadratic sequence, and to find the nth term we have to do something slightly different. Right here they gave us the nth term and they had to generate the sequence, but you'll notice it's not the same. You're going up by 3, then you're going up by 5. All right, you're going by 3, then you're going up by 5. So the amount you're going up isn't constant as it in here. All right, so you'll see there's a different pattern from that. If you look at the playlist over here for sequences, you'll see many examples of different types of sequences that you might find in the exam. So this playlist will take you to a whole heap of questions all about sequences and number patterns, and you can see the different types from there. So so that concludes question 10a and b. Other questions from this particular paper can be found in the playlist appearing in this region here. Other questions from sequences, as I mentioned, can be in the playlist over here, and you can subscribe to my channel by clicking on the link in the middle. Thank you for watching, and see you soon.